Brother Guy Consolmagno grew up in Detroit and then studied undergrad at MIT. His PhD in planetary science is from the University of Arizona Lunar and Planetary Laboratory. I'm a speech comm liberal arts major. In 1989, he entered the Society of Jesus, the Jesuits, and took vows as a brother in 1991. On entering the order, he was assigned as an astronomer with the Vatican Observatory. He has been curator of the Vatican's extensive meteorite collection, I believe, since. In addition to his continuing professional work in planetary science, Brother Guy studied philosophy and theology. He's the author of numerous, co-author of numerous scientific papers, books, articles, etc. I was just sitting with someone at the table who's seen him on TV several times. There's even an asteroid called Little Guy. In 2014, Brother Guy was awarded the Carl Sagan Medal for Outstanding Communication by active planetary scientists to the general public. And in September 2015, His Holiness Pope Francis named Brother Guy to be the director of the Vatican Observatory. So please welcome Brother Guy Consolmagno. Thank you.
It turns out that when you're made the director of the Vatican Observatory, you are ex officio a member of the Roman Curia. So if we can show the first slide here. Once a year at Christmas time, the Pope invites all of the movers and shakers, the people who run the church, into a big audience room. It's just a glorious room, as you can tell from the pictures. And what Pope Francis mostly does is remind people that they're being a little bit too worldly and too interested in their status. Well, I am in that picture. And if you, the next slide, way in the back, the seats are assigned, but do the next one. I think you can see a little circle. That's me. In the absolutely back, but I'm in the room. I am the director of the... Well, there I am, suddenly. I basically just wanted to introduce this little film to say there's a short film clip that gives you an idea of what the Vatican Observatory is, and so we'll start with that. Both science and religion are conversations about the universe. They're ways of learning how we interact with this universe. It's not simply a question of, is there a God, but there is a God, now what do we do? It's not just a question of, there are a bunch of stars, but rather, why are there stars? How do they work? How does that tell us how things work here on Earth? The interaction that I see in my own life is that religion gives me the reason to do the science.
Back in the papacy before Francis was Benedict, and one of his lines in a final elocution to the fathers of the general congregation was, "Go to the frontiers." Well, there isn't much more frontier than 3.7 billion years away.
The first official interest of the Church for astronomy started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to have an observatory to show that the Church is not against science, but the Church promotes good science.
They start out by having telescopes on the Tower of the Winds, and then on the walls surrounding the Vatican. As the city lights grow, and as the Italian government gives them back the territory out in Castel Gandolfo, in the 30s they build new telescopes on the roof of the Papal Palace in Castel Gandolfo, best telescopes of their era in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we build a new telescope in the dark skies of Arizona.
I'm Father Jean-Baptiste Kikwaya Eluo. I'm working in 3 projects. The first one is NEOS, Near Earth Object. So what I'm doing with NEOS is just observe them using our modern telescope VAT. The second project is meteors. I worked on very faint meteors, what we call shooting stars. And the third project is set fireball network. They will have 4 cameras here around Tucson so that actually we can monitor any fireball getting into the Earth atmosphere in the region.
This telescope, the Vatican Advanced Technology Telescope, it was the first of the new technology telescopes that has been considered pretty much the norm now in developing telescopes. With the advance of computer technology, we have the capability of bringing that advanced technology directly into our telescope. So it's an expandable, it's almost like it's a living machine, so it can grow as technology grows.
It is still very important to maintain scientific research at the Vatican, simply because there is still a lot of confusion about this relationship between science and faith. We are not out here trying to prove the existence of God by looking through a telescope. That's not what we're doing. But we can say that if we want to obtain any reasonable results looking through that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through commandments and through the Gospels to embrace.
Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the moon landing and they want to know, what was that like?
Very well.
If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and wondered, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's for lunch. What's more, if you believe in a universe that God so loved that he sent his son, then not only are you going to want to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as St. Athanasius said 1,500 years ago, was cleansed and quickened by the Incarnation. Then, doing science is an act of worship. Our history of using astronomy in religion starts out originally as a way of keeping track of time, keeping track of feast days. And one well-known example of this was, of course, in 1582, when the Council of Trent had told the popes to fix the calendar. Pope Gregory put together a committee of people, and the committee actually came up with a pretty sensible answer. I could go on for hours and all the mathematics and the details of it, but we have here a picture of a fellow named Christopher Clavius, Jesuit mathematician, who wrote the book explaining how the new calendar was going to work. Not only did they eliminate the 10 days and change the way that leap years work so that we wouldn't be shifting out of kilter, but sorry about that. 'Tis the season. But also, they worked out a new way of determining the date of Easter. Most of you probably have learned that Easter is the Sunday after Passover, or the Sunday after the first full moon after the first day of spring, which kind of works if you can work out when spring is going to be. What happens if the first Sunday is Passover? Well, then you go a week later. What happens if it's Sunday in one part of the world and Saturday in a different part of the world? Because by the 1500s, we're going around the world and we have missionaries in all different parts of the world. And how are they going to determine it? How are they going to calculate it? It turns out the new way of doing it is not based on astronomy, but based on a formula that imitates astronomy, a formula that would fit on one page and anyone could work out when Easter is going to be. But just for your convenience, in this book, Christopher Clavius tells you the dates of Easter from when the book was published until the year 5000. You heard about the Mayan calendar that was going to end in 2012 and we're all going to die. We're good to the year 5000. And if you can see on this, there's 2018, draw it again, and you can see that Easter is going to be on April Fool's Day, and Ash Wednesday is going to be on Valentine's Day this year. This was not a particularly great year. One of the things that was done in order to show the world why the calendar needed reforming was there was a tower in Rome, the Tower of the Winds, that had a meridian. Basically, you have a dark room with the wall to the south has a small hole that acts like a pinhole camera and focuses the light of the sun onto the ground. When it crosses the north-south line, you can see is it way, way towards the north because the sun is really low, like the wintertime, way high because the sun is very high and it's the summertime, or is it exactly halfway between? And the famous one that people talk about is in Rome, but frankly, it's a fake because you can't see the entire stretch of the passage of the sun. We discovered this. The BBC program, The Sky at Night, rented the room to measure and photograph the spot of the sun crossing the meridian line, only they were there too close to June, and the angle was so high that the light actually doesn't get through the hole in the wall, as we discovered waiting for it to come. But there are places where you can do this, especially cathedrals. And this cathedral in Bologna was the first one that a scientist named Cassini used. He not only was able to work out the calendar, but also he was able to work out the latitude and longitude of Bologna by measuring this, using this cathedral as a giant telescope, in effect. This was so useful that he got a job running the Paris Observatory, and he mapped out the first accurate map of France by setting up these meridian lines in churches all across France. He presented the map to King Louis, who said, "For all the wars where I've lost territory, this map has lost me even more territory." They found out France was a little bit smaller than they thought it was. But it also shows that the church was using its physical buildings as a way of getting to know the size and the shape of the earth and the passage of time, the beginnings of science. When you think of science in the church, you always think about Galileo, and I could talk for hours about Galileo. I've just finished doing a program for Now You Know Media, which is one of these wonderful places where you can get these 25-minute programs, 12 at a time. You can listen to them on your car. And they said, could you do one about Catholic scientists? Well, there are lots of Catholic scientists. One of them was Galileo. Yeah, he was a Catholic. He was a good Catholic before, during, and after his trial. His two daughters were nuns. He never married their mom. He was an Italian Catholic, but still. Galileo, of course, got into a bit of a fight with the Jesuits. This was a Jesuit who, Christopher Scheiner, and the two of them were arguing who was the first person to use a telescope to look at the sun and see sunspots. And when you look into the history, who was right? Was it Scheiner? Was it Galileo? It turns out it was actually an Englishman, Thomas Harriot. So much for being the first. The one thing that I do want to say about Galileo, 3 points. Galileo was a devout Catholic. Even after his trial, Galileo was actually never convicted of being a heretic. The conviction that when they said, we found you guilty of heresy, you can read the transcript of the trial. It's not what you think it is. It's Galileo saying, what did I do wrong? I'll change it, please. And they say, nope, sorry, we can't let you do that. Very odd. At the end, they said, so we found you guilty of heresy. It looks like they had written the verdict before the trial even began. And Galileo said, well, actually, you never did find me guilty of any heresy. So he was found guilty of vehement suspicion of heresy. And the famous scene where he has to abjure his teachings, what he actually says is, and writes and signs, is, I reject anything and everything in my writings which is contrary to the teachings of the church, without ever specifying any of those things. I mean, he could have been a Jesuit, right? It's just a fascinating, because the odd thing about Galileo, the more you dig into the history, the more you realize everything you know about Galileo is wrong, but the truth doesn't make the church look any better. The trial occurs after he's been doing what he was doing for 20 years, being supported by the Pope, being supported by the church, and nobody is really sure why the trial happened. It's one, you can go into the, read biographies. There are hundreds of biographies, and everyone gives a different story. The two favorite theories is, one, the book made the Pope look bad, and so he wanted to get back at Galileo. Quite possible. The second, if I had told you that some event occurred in America in October of 2001, most of you would think, oh, that was right after 9/11. If I was to tell you that some event occurred in America in January of 1942, you're thinking, oh, of course, right after Pearl Harbor. The Galileo trial occurred right after events just that momentous in the 30 Years' War. And the Pope was being accused of secretly supporting the Protestant side in the 30 Years' War because the Spanish were the other side and he didn't like the Spanish. It could have been something all tied up with the politics of the 30 Years' War. Nobody's ever been able to actually work out what that would be. The fascinating thing is, no matter what it was, the church was wrong in using its ecclesiastical authority for reasons that had nothing to do with religion. And that's why Galileo received the apology from Pope John Paul II in 1993. Enough of Galileo. Let's move on to the next slide. There was a lot of science from the time of Galileo up into the end of the 19th century, and nobody ever thought anything about that would be unusual. If you look into the science books of the 18th century, who are the people doing science? What does it take to be able to be a scientist? You have to have an education. You've got to have an interest in doing it. You've got to have the free time to do it. There was either noblemen, medical doctors, or clergymen. And in fact, most of science is just keeping records. And what do you call keeping records? It's clerical work, right? Why is it called clerical work? Because originally it was done by clerics. When you're a parish priest, you know how to keep records. And keeping records is 50% of doing science. And so science was done by the clergy. It's only in the politics of the end of the 19th century that people start inventing this. Oh, look at Galileo, he was a martyr to science. Well, no, he wasn't. Oh, look at all the other ideas that somehow the church was anti-science come up at this time. And to counter that, Pope Leo XIII establishes an actual national observatory. He also liked the idea that the Vatican city-state, which at that time was just the area around St. Peter's, nonetheless was an independent country. He establishes a Vatican observatory so that everyone can see that the church supports science. And in this image here, if you can see it, there's the coat of arms of Pope Leo XIII, which by coincidence has a comet in it, which I always thought was a nice coincidence. Next slide. One of the things they do is they join an international group that are going to photograph the sky. The sky is so big that one observatory alone can't photograph the entire thing, but they have 18 observatories with identical telescopes, all of them national observatories. The Vatican's one of them. They photograph the sky, and then they have to measure the dots of starlight on every photographic plate, measure their position, and come up with an atlas. You need a computer to do that. In fact, the Vatican had 4 computers. these nuns who worked at the Sisters of the Child Mary, and they were the ones who did the detailed measurements that came up with the original atlas of the sky. We now have a telescope under construction that will repeat what this survey did over a period of 50 years. We now have a telescope that will do it 3 times a week. By measuring the star positions and see how they move and see how the stars vary, you actually can get a heck of a lot of fascinating science. The old plates, meanwhile, we are scanning and digitizing so that we can compare where the stars were in 1890 with where we see them today. In the 1930s, as you saw, the Vatican and Italy came to an agreement, and the old papal territory up by Castel Gandolfo was given back to given back to the Vatican. And so this palace, which had been built by Maffeo Barberini, Pope Urban VIII, the Pope who Galileo and he got mad at each other, was turned into an astronomical observatory. And this is where I lived for the first 15 years that I was at the Vatican Observatory. In the next slide, you can see the top floor. That's where the offices of the observatory was. The next slide, that was my particular office, where that arrow is in the top floor. The next slide, that's the bedroom of the Pope when he's in town. So you're looking at the one guy who used to be above the Pope in the Catholic Church. However, our work and the papal work during the summer got so involved that we finally moved to wonderful quarters in the gardens I don't have pictures of. And we moved out there in 2009. We'd never moved back. It's great to think that you're living in a palace. That building was not built with indoor plumbing or central heating or the internet in mind. It's a whole lot nicer where we are now. But the light pollution also made it impossible to do astronomy there. And that's why we have this telescope, as you saw in the film, in Mount Graham. Next. It's located out there in essentially the middle of nowhere. And I could talk forever about, go back one, just that beautiful view of the mountaintop itself. This is important to remember. Astronomy is very detailed and it's very mathematical and it's very tedious at times, but it's also beautiful. And it puts you in beautiful places to look at beautiful things. The telescope itself is a marvelous machine, and again, I could talk for hours about that, but I won't. What I will mention is that we have astronomy that not only uses the telescope, but also does theory. This was a gathering of Nobel Prize winners and other experts in the field of cosmology in a meeting that was held a year ago in May in honor of Georges Lemaitre, a Belgian priest who was not a Jesuit, he was a diocesan. It is possible to be smart and not be a Jesuit. Georges Lemaitre had 2 doctorates, one from Louvain, one from MIT, and he was the kind of mathematician who could read mathematics the way you might be able to read poetry. And in the 1920s, he was reading Einstein's theory of general relativity and what it said about the universe, and he said, you know, in these equations is the realization that the universe could be expanding. And if the universe is expanding, we ought to be able to observe it. And in fact, they had observed it by then, though they didn't have the Hubble law yet. And if the universe is expanding now, I can envision a cosmology where it was once much smaller. And he referred to this beginning point as the primeval atom. And an Englishman who hated the idea that the universe might have a beginning because he thought it smacked too much of Genesis, made fun of it and called it the Big Bang Theory. The Big Bang Theory was invented by a Catholic priest. And 50 years after his death, we had a meeting where Pope Francis greeted him. Now, you'll notice that book that he's holding does not look like a science textbook. At that same meeting, I gave him a children's book written by the children of Our Lady Queen of Martyrs Parish, where I had studied 50 years earlier. And so he's holding this children's book and delighted in the thought that we have both kids at the same school that taught me science and religion. The nuns taught me science and religion. The nuns taught me math. The nuns taught me physics. And the physics that is going on and making us envision how the universe could have begun and where it may be going in the future. We've got a dozen astronomers, 11 astronomers, at the Vatican Observatory now. Our goal is to be small but good. We're halfway there. And as you can see, if you look over this list, they come from all over the world. We even have a fellow from Texas A&M. I hope there's nobody here from Texas A&M. He wound up going to Oxford after that. We have an Englishman, we've got an Indian in this one, and then the next page, the African who you saw in the film, Paul Gabor. We have at the dinner table 7 languages, and Paul speaks all of them. It's astonishing. And we cover every field of astronomy that there is. But I want to end by going back to Michigan, going back to the summer cottage that I spent my summers in as a little kid. Because there's a moment I remember, rainy day, when I couldn't go out to play, and my mom, to entertain me, comes out, deals the card. We're sitting in that porch there. I can remember hearing the rain. And as we're playing rummy, I suddenly had one of those little insights that you have when you're 10 and suddenly you see the world. And I'm thinking, she's a grown-up. I'm a kid. She could win this game anytime she wanted. Why is she playing with me? It's her way of telling me she loves me. And that's what I experience in the lab. God and I are playing a game together. And it's not a game of who's going to win. It's a way that God can engage me in his universe, have fun, and say, every time I come across and solve some puzzle he's set for me, to be able to say, isn't that cool? Let me show you the next one. That sense of joy is what it means to be a scientist. That sense of joy is why I say doing science is an act of worship. It's the same joy that C.S. Lewis talks about in Surprised by Joy. So I hope you've had a great lunch. Thank you all for having me here.